Hi, welcome to this new session of Operation Modeling and Simulation. In this opportunity, as we already discussed in previous week, we're going to talk about one particular approach, which is about multi-criteria decision making. The way how we're going to cover this approach is going to be very simple. I'm going to explain you a little bit the theory with some examples. Then we're going to do a real example, or a very realistic example, just by following the steps of this methodology. And we're going to do an exercise using Excel. So let's start with the theory first for this, and to move forward to the exercise. So in general, we face decisions to be made in general, right? So we're not prevented for making decisions, but also we are encouraged to make decisions anytime, like which product we want to buy, which TV show we want to watch, where to go, where not to go, who we can meet, which modules shall we take, which program should we get registered to, or which country shall we visit, which food shall we eat, which medical product shall we use. So there are many decisions that we face all the time. But more importantly is that regardless the decision, always there is what we call an objective that we want to achieve. So we are making a decision because we want to achieve an objective. And in order to fulfill that objective, or to achieve that objective, there is always a certain amount of criteria that we need to consider in order to judge which one is the best decision that will help us to achieve that objective. Then we will see that there is not always one alternative, or there is no only one choice, but there could be many. The thing is that we should be able to know which one of those elements that triggers our main decision are the most accurate or the most useful ones in order to achieve our objectives. So just to explain this with some examples. So just give me 2 examples. The first example, let's say example A. We are looking to buy some food, specifically for our lunch. So, and imagine that for some reason you decide that you want to get some soup for your lunch. So which soup are you going to buy, right? Nowadays, everything needs to be done online, but in the past, we should go to the supermarket and see the rows. Now, regardless this pandemic that we are currently suffering, still we can access websites in order to select the product. So still we need to make many choices. So imagine that we need to select this food soup. Therefore, you need to have some criteria in your mind. So many people will have different type of criteria. So we have different type of reason to select one soup or another. Imagine that for some reason you got 3 main criteria, so 3 reasons that you should consider in order to select the best soup. So we can say, for instance, one of them is price, the other one could be flavor, or the other one could be nutrition. Right. So for instance, something that is not cheap, or something that is expensive, or something nice flavor with some level of nutrition. You want vegetable, you want meat, you want all these combinations. So you may have different types, right? So regarding to all this, also you will face different type of products, right? Brands, for instance, you can have products from Tesco, from Sainsbury's, from Iceland, many places. So, and different places will offer different type of products. So you need to assess which is going to be the best choice for you. At least you know those 3 criteria, but which one is going to be the best, or which criteria important the most? So we need to make a decision. And then which product is going to be. So imagine that, for instance, we got 4 products. For instance, we got, the Yorkshire roast chicken and vegetable, Tesco finest sweet potato and coconut, and for instance, tomato and basil soup with double cream. So we have many types. So which one is really going to be, of course, will depend on many people. So one of the things that we need to be able to do is try to understand which one of those criteria or which one of those reasons are more important, are more, let's say, weighed the most. So for instance, it's going to be price, the element who will make the difference, it's going to be the flavor, it's going to be the nutrition. So multi-criteria decision-making analysis is about to analyze the situation, which is very common and then that you face on a daily basis. But not everything is about soup, right? Or not everything is about product. You can have other type of problems. So let's see this example B, for instance, where now it's not about to select a product, but also to select a service provider. So you want to develop a project, and then you need to, let's say, hire some services, and then you need to identify a service provider that will help you to complete the required tasks. So which element, which criteria are you going to consider in order to fulfill this? Well, it could be service quality, isn't it? Could be the price, or could be the delivery option. Of course, there could be many others, but just to give you some examples. So you more or less, you are getting the idea. We need to identify something that we want to get, and what are those criteria that will help us to make the best choice in order to get that more efficiently, or let's say, or quickly, or at a less cost, depending on your objective, of course. So for instance, in this particular case, you will be able to use those criteria to assess number of service provider, and eventually you will be able, for instance, just to rank which are the best 5 options for as a service provider. So which means that the multi-criteria decision-making analysis will help you not only to identify which is the best solution, but at least to get some sort of a ranking that will help you to select. Because in the previous case, when we talk about the soup, we say, for instance, the tomato and basil soup from Tesco is for instance, is the best one based on your criteria. In this case, we can say, for instance, that the service provider number 10 is the best one. But what about if those products are not available? And that is something very interesting from operations management, that we're not looking at the optimal, the unique optimal solution. We're looking at a range of potential solutions that you can select in case one of the optimal solutions are not available. For instance, what happens if you said that one particular product is the best choice, and then that product is not available anymore? So what was the purpose in doing all this, all these multi-criteria decision-making analysis? Well, because we can generate a ranking of possibilities. It can tell you, well, if the first choice is not possible, all the time you can do a second, a third, a fourth, and so on. So those examples, as you can see, are very complex examples. Even if you deal with them in a regular basis, probably in your own professional life, or in your career, or in your normal life, and outside university, or outside your work, all the time you need to face multiple criteria, and some of them, those criteria might be conflicting. So which one, for instance, price or nutrition? Until people says, well, price is good, but also nutrition is also important. So therefore, in order to try to embrace this challenge about making decisions with a good impact in terms of having the right or the best set of alternatives, or the best set of decisions that can help you to commit to the objective, we are going to learn how to use a method which is called analytical hierarchy process, and is one way to solve these multi-criteria decision-making problems. Right? There are many other methods. We're only going to focus in this analytical hierarchy process, or AHP, as you will know. And of this is plenty of literature, is plenty of information, but this session is really about to give you an introduction about this, right? In the next video, we're going to see an example, and then in the next video, we're going to see how to do that in Excel. So the analytical hierarchy process, right, is considered as a multi-criteria decision-making method introduced by Sati in 1970s, so it's very old, more than 50 years. It's a way to help decision makers to make informed decisions by quantifying subjective belief within a mathematical framework. So we will use some matrix structure. So we need to learn how to operate matrices. But this is because this is a method, it's, let's say, a tool. You don't need to invent the wheel. You don't need to kind of learn new things. It's just about to apply the method, and then by using the right tools like Excel, you can do these mathematical operations very simply, to be honest. AHP It's all about relative measures of different quantitative and quantities, and it's the intersection of the field of decision analysis and operational research, which means that we're looking to provide a good decision considering an optimal solution. Now, AHP is very popular in several fields like supply chains, project management, big data, business analytics, transportation, anywhere where you need to make a decision, this method is very useful. So let's going to have a quick view about how this process looks like, right? The process is quite straight, so it's not for you really to question the steps, it's about to understand what you really need to do. Of course, all the time you can look for more information about multi-criteria decision-making analysis and different methods that you can use to solve these problems. But the idea of this subject is for you to learn a tool that can help you to better analyze current criteria to achieve one particular decision that will help you to commit or to achieve one objective. As any method, this process follows several steps, right? So the first step is to define the ultimate goals of the process. So you need to know what is that you want to achieve, right? Normally for this in real life, you would like to run some focus group, you would like to run some interviews that can help you to really gather what are those objectives. Once you identify those objectives, the next step is to define what are the alternatives that you want to put in place in order to achieve those objectives. For instance, I would like to build something, I would like to buy something, I would like to generate some sort of a project, so what is all the things that I would like to do in order to achieve my goals? However, also in organizations, sometimes goals are already in place and alternatives are already in place. So when that happens, this is very useful because then we just can assess by using this method which alternative will be the best to achieve that objective. But we will learn that in order to better understand the objective, we need to understand what are the decisions that we need to make in order to achieve that objective. And because this is about decision-making process, we also need to understand what are the criteria to connect to those decisions. So what are all those things that I need to consider in order to know which is the best decision? So I need to list the different criteria by which you assess the above alternatives. Of course, this can involve also sub-levels of criteria and sub-criteria. So a criteria might be composed by several sub-criteria. For instance, a criteria could be a color, and then a sub-criteria could be, for instance, pink, blue, red, brown, etc. Then once you do that, once you identify the objectives and then you identify the alternatives and also you identify the criteria to achieve those goals or make those decisions happen, you will build what we call the hierarchy tree. So this means that in a very graphical manner, you will represent all these decisions, all the objectives, all the criteria and alternatives. Let's see how this looks like. For instance, this is an example. Imagine that you're looking to buy a car, right? So some criteria to consider this are cost, safety, style, and capacity. But cost, for instance, may consider several sub-criteria like purchase price, fuel cost, maintenance cost, and resale value, for instance. Safety doesn't consider any sub-criteria. Style doesn't consider any sub-criteria, for instance. And capacity, for instance, could be cargo or passenger. And then alternatives, I can have, for instance, 6 cars to select in order to know which is the one that I really want. But in order to know which one I really want, I need to be able to assess each of those models regarding to those criteria and also criteria that I put in place. Then once I do that, we start with the second part, which is about to do the pairwise comparison of each criteria and sub-criteria in order to establish their weight. So then I want to know how important each criteria is, right? So I need to know exactly if criteria 1, for instance, if I go back, for instance, you want to know cost, safety, the style, and capacity, which one is more important, right? Is cost is more important, safety is more important, style, capacity, and which one is the second more important, and the third more important, and the fourth more important. So by doing the pairwise comparison, we're going to learn to do so. We're going to get the figures that will let us know exactly which one is more important. And then once I do that, I need to do the pairwise comparison of each alternative against each criteria to establish their weight as well. And then by combining those, we call it the global summation of this weight, we can get effectively the best alternative. The final step, right, is we need to identify the consistency ratio. So this means that once, for instance, if I go back to this picture, if for instance, if I identify that cost is more important than safety and more important than style and capacity, is that really true, right? Is that consistent, right? For instance, so because eventually when people in organization, because this also is driven by real life challenge, people in organization, depending on their proper personal interest and goals, people will try also to influence what is more important and what is less important in order to try to, let's say, to drive a particular decision or to achieve one particular objective depending on their own desires. So this method also helps us to realize how valid, how consistent this information really is, and that is being calculated by what we call the consistency ratio. So in order to make the pairwise comparison, when we will see an example about this later, we basically, what we do is that we compare each criteria against each other, right? We try not to replicate the comparison. So for instance, if I have three criteria 1, 2, and 3, I will compare criteria 1 against 2 and 3, and then criteria 2 against criteria 3, right? I don't need to do, for instance, criteria 3 with 1 or 2 with 1, because I already did 1, 2, and 3. So what I do is that we use the scale of sati, in where we say that, for instance, if when we compare two criteria, they are equally important, the result is 1. If one criteria is equally to moderately preferred or more important, is 2. And if, for instance, and in the extreme, if one criteria is extremely more important, it's going to be 9. Right, and this is what we call the AHP scale. So therefore, by using this hierarchy 3, and then by using this SATI scale, we are going to be able to assess if each criteria is more important than other. Then about the consistency ratio, I'm not going to go too much in detail now. I'm going to have to explain you what is this about. So because we will see an example in practice, so we will learn how to calculate this consistency ratio. So basically, it's a ratio that should be normally around 0.1, right? I will explain you what that means in order to accept that the information provided by the stakeholders or the information that you put into the system to calculate the weight of each criteria is really makes sense. So it's really consistent, right? Of course, it's not that, let's say, type precise. It could be, for instance, any value under 0.1 is good, but if we get 0.2 sometimes, or we get 0.15, it's also acceptable. So basically, to calculate the consistency ratio, we follow certain steps. So basically, we need to operate the pairwise comparison matrix by the priorities. So basically, and then we get what we got the weight in sum. And then when we divided this element by the sum obtained in step 1, for instance, we get what we got, what we call the priority value. And then that helps us to identify the average value of all these vector that will help us to calculate what we call the lambda max. This is useful because in order to calculate the consistency ratio, we have a formula which is called the consistency index, right? And the random index. So when I divide the consistency index in the random index, I got what we call the consistency ratio. So the consistency index is equal to lambda max, as we already know how to calculate it, minus n, where n is the number of criteria, so the number of elements that I'm evaluating, divided by n minus 1, right? So clearly, in order to make this method works, we should have at the very least 3 criteria. Otherwise, this method might not be worthwhile using it. So once we get the consistency index, we need to get the random index. So for the random index, basically we use the scale of SATI as well. Again, so it said that if you have, for instance, if your n is 3, your random index is 0.58. If you have 5 values, your random index is 112. If you have 10 values, your random index is 149. What happens if you have 11 or 12 values? Well, the process is very complex, right? And in order to compare criteria, we have to be consistent as well. So if we are having more than 10 criteria, right, to be analyzed or to be assessed, probably something is not very right. That means that we have maybe some duplicities in those criteria or in those elements that we're considering to make a decision. Normally, it's well understood that 10 criteria is mostly quite acceptable in order to make a good decision. Beyond that will make the problem even complex, and then will make things more difficult to be calculated. So therefore, historically, 10 criteria as maximum are accepted. So once we got the random index, then we will know if what we got is acceptable or not by calculating what we call the consistency ratio, which is about the consistency index divided by the random index, right? So considering this, what we're going to do now in the next video, that I'm really going to show you how this really works in practice. So I'm going to make an example. So we're going to make these calculations that I understand that at some point may seem complicated, but they're not, because basically you just need to know how to create your Excel file in the, we see an example in Excel later. And then you just need to put the figures in the right place, and then the calculations that also you will learn how to make them in Excel. So we can say as a summary that we have the main application of this method is to understand the business performance management to support them, combine individual key performance indicators against individual as one key performance indicator to provide weight. And is one way to solve this is this analytical hierarchical process that can help us really to gather the relevance and the importance of each criteria. So in our next video, I'm going to show you an example on this method. I hope that you have at least enjoyed or understood a little bit what this method is about. There's plenty of literature online, so you can check what it's about. But in our operation model and simulation module, we are looking basically to try to understand how we can apply a method in order to assess our decision, but also to assess the main of our criteria. Remember that you already learned witness, which is about how processes can be represented and how can be understood in terms of their behavior. You have also seen system dynamics, in where you can identify variables and how they connect. Now it's about to know how relevant each parameter or each variable is to make the best decision, right? So in the next video, we will see an example. Hope you have enjoyed this session.